this is the part 2 of our course project. So I'm going to explain the answers that I provided in this activity. So as you can see, this is our problem. So we have problem number 1 here. So which is we're going to find the prefix length. Okay, so let's proceed with number 1. So my explanation. So in order to find the prefix length, so we need to know the subnet mask. Okay, so since the subnet mask is already given here, the 255.255.255.224. So this is our subnet mask, and the prefix length is the one that we are going to solve. So my solution for this is we have to convert subnet mask to binary. So by using this table here that I provided, so we can convert subnet mask to binary. So using these values here, this row here. So how did we get this one? Okay, so we get this one by the formula 2n, this one here, 2n to the power, 2 to the power of n. So this means that we have to raise 2 from 0 to 7, since we have 8 bits here. So 1, 2, 3, 4, 5, 6, 7, and 8. So 2 to the power of 0 is equals to 1. Why? Because any number raised to the power of 0, the answer is 1. So that's why we have 1 here. And in order to get the next, the 2 here, so we need to, again, 2 to the power of 1. So 2 to the power of 1 is equals to 2. So next, 2 to the power of 3 is equals to 4. And 2 to the power of 4 is equals to 8. 2 to the power of 5 is 16. 2 to the power of 6 is 32. And 2 to the power of 6 is 64. And 2 to the power of 7 is 128. So again, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. And 2 to the power of 7 is 128. So that's how we get this value here. Okay? But I think it is much easier to just double the number starting from 1, like this one. So for example, 1. So if we double this one, 1 plus 1, so that makes 2. And then 2 plus 2, that makes 4 here. And then 4 plus 4, 8. And then 8 plus 8, 16. And then 16 plus 16 is 32. And 32 plus 32 is 64. And 64 plus 64 is 128. So the same. So now we are going to convert the subnet mask to binary. So let's do first the first octet. So we put it here, and the second octet also goes here. The third octet also goes here, and the fourth or the last octet here. Okay, so in order to convert, so but first remember that binary number only uses 1 and 0. This one. Okay, so remember 1 means yes and 0 means a no. Okay, so let's try this one. So in order to get 255, we have to add all the values here. So let me ask a question. Is 128 can be added to get 255? Of course, yes, because 128 is lesser than 255. So meaning, we can add 128, we can use 128 in order to get 255. So that means it's a yes. So we put here 1. So next, let me calculate first. So 128 plus, next is 64 can be added also. So let's try. 128 plus 64 equals 102. So also 64 can be added so that we can get 255 as well as 32. That's why we put 1 here. So and also 16 and 8 and 4 and 2 and 1. Okay, so let me check this one first. So look here. So this is our to confirm, we have to add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And then the answer is 255. So let me check. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So we got 255. So meaning in the first octet here or here, so its binary form is 1 1 1 1 1. So we have 8 ones. Okay, so let's move on to the next octet. This one here. So since the same number, so we just put our copy all the ones here. Okay, so same thing with the third octet. So 1 1 1 1 1. So in the last octet 224. Okay, let's find out. So is 128 can be added or can be used in order to get 224? Yes. Is 64 can still be added or can be used in order to get 224? Yes. Is 32 can still be added or can still be used in order to get 224? Yes. Is 16 can be added? No, because in this 128 plus 64 plus 32 is already 224. So that's why this one is a no, is a no, is a no, is a no, and here is a no. So this is the second octet here, the last octet here. So we're going to confirm by adding it. Okay, so 128 plus 64 plus 32 equals 224. Okay. So again, in order to get the subnet mask in binary, so we are going to count the number of ones in the first octet here. So we have 1, 2, 3, 4, 5, 6, 7, 8 ones. So we have 8 ones here. And the second octet here, we also have 1, 2, 3, 4, 5, 6, 7, 8. So same thing. So on the third octet, we also have 8 ones. So this one. And on the last octet, we only have 3. So 1, 2, 3. So 1, 2, 3, and the rest is 0. Like this one. Okay? So since we already know the subnet mask in binary, so this is the binary form. So to get the prefix length, since we were going to find the prefix length, so we are going to count the number of ones. So as you can see here, we have 8 ones, and another 8 ones, and another 8 ones, and 3 ones. So meaning 8 plus 8 plus 8 plus 8 is 27, plus 3 is 27. So 8 plus 8, 16, plus 8 is 24, plus 3, so it's 27. So therefore, so our prefix length is 27. Okay, this one. So let's go to problem number 2. So I have prepared here a screenshot so that we will not scroll up and down, back and forth. So that's why I made this screenshot. Okay, so our problem number 2 is we're going to find or we're going to get the broadcast address here. So in order to get the broadcast address, so we need to know the network address and the subnet mask. So this one, 172.201.95.32, and the subnet mask is 255.255.255.224. So let's go back to our. Okay, so we have a given here. So our network address again is this one, 172.201.95.32, and our subnet mask is 255.255.255.244. So we're going to find the broadcast address. So this is my solution. So first, to get the broadcast address, we need to follow 2 rules. So rule number 1, if the octet in the subnet mask is 255, so if it is 255, then we write down the network address octet value. So number 2, if the octet in the subnet mask is 0, then we write down 255. So this one. But if the octet is not equal to, if the octet is not 255 and 0, so if not 255 and 0, then we're going to use a formula. So this is the formula. 256 minus octet, which is not 255 or 0, so is equals to multiplier. So we need to get a multiplier for this one. So then, after that, we are going to find a number using our multiplier here, which should be greater than and nearest to the network address octet. Then subtract 1. I think this one is not needed anymore. This is about the subnet. So let me delete this first. So again, to find, we are going to find a number using our multiplier, which should be greater than and nearest to the network address octet. Then subtract 1. So in our example or in our problem, so we have a given of network address, this one, 172.201.95.32, and the subnet mask is 255.255.255.224. So again, based on our rules, if the octet in the subnet mask is 255, so since our first octet here is 255, so meaning we are going to use, or we are going to write down 172. That's why in our broadcast address, we write here 172. Okay, so on our second octet, we still have at 255. So we write down this one again in the network address 201. So this one. So next is our third octet. We have again 255. So our rule is to write down again the 95 here. So that's why we have 95 here. So next is the last octet. The fourth octet is 224. So based on our rules, if the octet is not 255 and 0, so meaning we are going to use the formula here. Okay, so the formula would be 256, So So the formula 256 minus 224 is equals to 232. Let me confirm this first. 256 minus 224 is equals to 32. So now we have a multiplier that can be used on our next the multiplier is 32. Okay, this one. So we are going to base again, then find a number using our multiplier which should be greater than and nearest to the network address octet, then subtract 1. So here we're going to find using our multiplier here. So our octet in the network address here is 32. Since we also have 32 on our multiplier, so we cannot use this one because they are the same number. So we need a greater than 32, greater than 32. So based on our multiplier, we have to add 32 plus 32. So we're going to use the multiple of 32, this one. So 32 plus 32 is 64. You can also use 32 times 2, 32 times 3, 32 times 4, and so on. So it's the same thing. So this time I use 32 plus 32 is equals to 64. So now we have a new number which is now greater than 32, and this is the nearest of 32. So based on our multiplier. Okay, so again, so we are going to subtract 1. So 64 minus 1 is 63. So meaning, so our broadcast address here, the last octet is 63. So therefore, our broadcast address is 172.201.95.63. So this is our final answer. Okay, so let's move on to our problem number 3. So our problem number 3 is we are going to find the subnet mask. So in order to get the subnet mask, we are going to know the prefix length, this one. So the prefix length is 25. So let's go back. Okay, so we are going to find the subnet mask, and our given is prefix length is 25. So this is all we need in order to find the subnet mask. See the subnet mask here. Okay, so our solutions for this is, first we have to convert the prefix length to subnet mask binary form. So our prefix length again is 25. So first we're going to visualize. Okay, so visualize our binary form. So as you can see here, in a binary form, we always have, in this first octet, we always have 8 bits. Okay, in the second octet, we also have 8. And the third octet, we also have 8. And also the last octet, we also have 8. So we're going to put ones in every octet of 8 until it reaches 25 of ones. So in our example here, we have 8, and then another 8 here, another 8 here, and 8 here. So 8 plus 8 is 8 plus 8 is 16, and then 8 plus 16 is 24. So we need 1 in order to get 25. So in this case, 8 plus 8 plus 8 plus 1 is equals to 25 ones. So our subnet mask in binary form would be 1 1 1 1 1 1. So 8 ones, that another 8 ones, that another 8 ones, and also we have only 1 here, and the rest is 0. Okay, so this is our subnet mask. So then we're going to convert the subnet mask binary form into decimal. Okay, so in order to get the decimal form, we're going to use again this table here. So again we use again this one, this value here. So our 1, 2, 4, 8, 16, 32, 64, and 128. So we are going to plot down these 8 ones here on the first octet, this one here, and also plot down, we're going to put it down here on the second octet, and also these 8 ones on the third octet, and also the last one into the fourth octet. So we're going to calculate. Okay, so this one. So since this is 1 1 1 1 1 1, so we have to add all this value here. So meaning 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. This one here. So our first octet is 255. Now let's move on to the second octet here. So we are going to add the value of 1 here. So again, we are going to add the same thing, just like the first, and we get 255. So our second octet is 255. And again, the third octet is also 81. So meaning we are going to use again the value here, all the values here. Okay, so 128 again, same thing, is equals to 255. So our third octet is 225. So for the last octet, we only have one here. So on the rest is zeros. Okay, so meaning we only have 128. So 128 plus 0 plus 0 plus 0 plus 0 plus 0 is equals to 128. So therefore, we're going to put down all these octet here. So therefore, our subnet mask is 255.255.128. So this is our final answer. Okay. So let's move on to our fourth problem. So our fourth problem is we're going to find the gateway address. So in order to find the gateway address, okay, this one, so we only need the network address. So what we're going to do here, so our solutions, the first thing to do is to copy the network address first 3 octets, then add 1 to the last octet. So meaning, if this is our network address, 10.78.128, so we only need to copy the first 3 octet. So this one. So that's why we have 10.10.78 blank. So again, the last octet we are going to add 1. So this one. So meaning 128, because this is the last octet here is 128. So meaning we are going to add 1. 128 plus 1 is equals to 129. So this is 129 here. So therefore, our gateway address is 10.78.129. So this is our final answer. Okay. So let's move on to our problem number 5. Let's move on. Okay. So what is our problem number 5? So our problem number 5 is to get or to find or to get the binary of the IP address. So in order to get so we need to convert the decimal form IP address into binary form. So in order to get the binary form, we have to know the network address. So this is our network address, 192.84.235.0. So again, you go back here. Okay, so we need to find the binary of the IP address. So our IP address or network address is 192.84.235.0. So let me check. 192.84.235.0. Okay. So first, we need to convert the network address into binary form. Okay. So again, using our table here, so we can understand this easily again. So we need again these values here. Okay, so to confirm this, we are just going to add. So we are going to find the binary form of 192 first. Okay, so again, we know this already, how to get this by adding these values here. So again, 128 can be added to make 192. Yes. What about 64? Can we still add this one in order to get 102? Yes. What about 32? No, because if we add, if we add 128 plus 64, so we have 192. So it's already 192. So the remaining would be a no. So we'll put all zeros here. So this one. So 128 plus 64 plus 0 plus 0 plus 0 plus 0 plus 0 is equals to 192. So what about the 84? So again, can we use 128 to add up to get 84? No, because 128 is greater than 84. So it's a no, so we put here 0. So how about 64? Can we add 64 in order to get 84? Yes. So it's a yes, so meaning we put 1 here. So 64, can we add 32 in order to get 84? No. No, because it's already enough. So 32 is too big. So what about 16? Yes, we can still add this one. What about 8? No. What about 4? Yes. And what about 2 and 1? And it's a no. So I'll show you here why. So 84. So we have 1 and 64. So 64 plus 16. Where's my calculator? Oops. Wait. Okay. This one. So again, 64 plus 16 plus 4 is equals to 84. Okay, so this one. So let's proceed with the third octet. So we are going to get the binary form of this one, 235. So again, can we add 128? Can we use 128 in order to get 235? It's a yes, so we have a 1 here. And what about 64? Yes, we can still add 64 in order to get 235. What about 32? Yes, we can still add 16. No, we cannot use 16. So I'll show you again. So 128 plus 64 plus 32, that makes 224 already. Okay, so we only need 235. So we cannot use 16. What about 8? So what about 8 here? Yes, we have, that's why we put 1 here. So let's add 8 plus 8 equals 232. So we have 232. Since we need 235, so we only need 3. So that's why in 4, can we use 4? No, that's why it's a 0 here. This one. Can we use 2? Yes, because we need 3. So that's why we have 1 here. Can we use 1? Yes, because we need 1. Okay, so that's why we have 128 plus 64 plus 32 plus 8 plus 2 plus 1 is 235. So let me check this one. 128 plus 64 plus 32 plus 8 plus 2 plus 1 is equal to 235. So this is our third octet binary form, this one. Okay, so our last is 0. So we also put all zeros here. So 0 plus 0 plus 0 plus 0 plus 0. So 8 zeros is equals to 0. So our binary form 192. So we have this one. That's why our binary form is 1 1 and then 6 zeros. So 1 1 0 0 0 0 0 0. What about the 84? This one. This one here. So we have 0 1 0 1 0 1 0 1 0 1 0 0. So this one. Or 6 this one. So our third octet, we have 235. So this is its binary form is 1 1 1 0 1 0 1 1. So this one. 1 1 1 0 1 0 1 1. Okay, so our last is 8 zeros. Okay, so therefore our binary of the IP address is 1 1 1 I mean 1 1 0 0 0 0 0 0 that 0 1 0 1 0 1 0 0 that 1 1 1 0 1 0 1 1 that 0 0 0 0 0 0 0 0. So this is our final answer. This is our binary of the IP address. Okay, so let's move on to our sixth problem. So let's put it here. So our sixth problem, where's the sixth problem? Okay, so we need to find the broadcast address. So once again, in order to get the broadcast address, we need the network address and the subnet mask. So we have our network address, which is 192.84.235.0. And we also have our subnet mask 255.255.255.0. So we'll go back. So this is, so we need to find the broadcast address and our given. So this one 192.84.235.0 and the subnet mask is this one. So our solution, so remember our rules. If 255, so we need to write down the network address on the octet. Okay, So just like here, our subnet mask. Okay, this is our subnet mask. So our first octet in our subnet mask is 255. So meaning we are going to write down the first octet also in the network address. That's why in our broadcast address here we have write down the 192. So next, on the second octet, we have 255. So based on our rules, again we're going to copy the second octet on the network address, which is 64. So that's why we have a 64 here. See? So in the third octet in the subnet mask is 255. So meaning we are going to copy the 235. So that's why we have 235 here. So it's easy. So the last octet is 0. So remember our rules. So if the subnet mask is 0, so we are going to write down 255. So this is the answer. Okay? So all in all, we have 192.84.235.255. So therefore, our broadcast address is 192.84.235.255. So this is our final answer here. Okay, thank you. Now let's move on to our seventh problem. Okay. So our seventh problem would be, we're going to find or get the prefix length. So again, in order to get the prefix length, we need to know the subnet mask, which is the subnet mask is 255.255.255.192. So let's go back. So again, our given here, we need to find the prefix length, and our subnet mask is our given 255.255.255.192. So first, we're going to convert the subnet mask to binary form. So we're going to convert the subnet mask to binary form. So again, using our table here, again, we will use this value again to add up to get our octet. Okay. So our first octet is 255. So again, we put it down here. The second octet is 255. We also put it down here. So our third octet is 255. Again, we put it down here. And the last octet is 192. We also put it down here. So again, we're going to get the value. This one here. Okay? So again, is 128. So I think 255 is repeated already, okay? So we know that 255 is 1, 1, 1, so 8 ones. So we have 8 ones here. And the second octet, we also have 8 ones. So because it's just the same. And on the third octet, it's just the same. So 8 ones. And on the last octet, we have 192. So we're going to solve this one. So can we use 128 to add up in order to get 192? Yes. So that's why we have a 1 here. So can we still add 64 in order to get 192? Yes. Okay? yes, we can still add 64. That's why we put 1 here, because it's a yes. So can we still add 32, 16, 8, 4, and 2, and 1? No, we cannot add because 128, let me check. 128 plus 64 is already 192. So we already have reached 192. Okay? So the rest would be as, I think, yes, 6 zeros. Okay, so in order to confirm this, we are going to add all the values. So again, we already did this one to the other problem. So if we have 255, so we all add this one here, the values here, because we all have ones here. So again, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equivalent to 255. So the same as here, it's equivalent to 255. And also for the third octet, we have 255. And for the last octet here, 192. So we have 128 plus 64. So plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 is equals to 192. So now we're going to, since we're looking for the prefix length, so we're going to count the number of ones. So in our first octet here, so our first octet is we all have 8 ones. The second octet also we also have 8 ones. On the third octet we also have 8 ones, and on our last octet we only have 2 ones. This one here. So all in all, 8 plus 8 plus 8 plus 2 is 26. So 8 plus 8 again is 16, plus 8 is 24. 24 plus 2 is 26. So therefore, our prefix length is 26. So our final answer is 26. Okay, let's move to our 8th problem. So problem number 8. Okay. So our problem number 8, we are going to get, or we're going to find the broadcast address. Okay, so again, in order to find the broadcast address, we have to know the network address and the subnet mask. Okay, so our network address here is 172.99.184.64, and our subnet mask is 255.255.255.192. So this is for problem number 8. Let's go back here. So again, we have to find we're going to find the broadcast address. So our given here is the network address and this subnet mask. Okay, so we already did this one just like before. So we have a rule: if 255 in the subnet mask, so we are just going to copy, write down the octet of the network address. So meaning we have 172 here. So coming from here. So again, we still have again 255. So we just copy 99 here. So that's why we have 99 here in our broadcast address. So again, 255. So we are going to copy again 184 on the network address. And we put it down here on the broadcast address, 184. And now for the last octet, we're going to solve this one because 192 is not is not 0 and it's not 255. So meaning some people call this one funny octet. So we will solve this funny octet here. So using our formula again, 256, so minus 192, this one, 256 minus 192. So we got 64, and this 64 becomes our multiplier. So again, we're based on our rules. After getting the multiplier, we're going to find a number that is greater than 64, this one here, on our network address. So greater than 64, and nearest than 64. Okay, so we're going to find greater and nearest than 64. So by using our, again, our multiplier, 64. So 64 is not greater than 64. It's equal, right? So we need to find a number which is greater than 64. So since they are the same number, so we need to find a number that is greater than 64. So by using our multiplier here, so again, I'm just going to add 64 by itself. So 64 plus 64 is equals to 128. So let me check first. 64 plus 64 is equals to 128. So next, we're going to subtract 1. So according to our rule, so 128, so here, 128 minus 1, so we have a 127. So this is to fill our gap here, so in the blank. So meaning our broadcast address is 172.99.184.127. So therefore our broadcast address is 172.99.184.127. So this is our final answer. Okay, let's move on to our 9th problem. So problem number 9 would be, again, we're going to find the binary of the IP address. So again, in order to get the binary of the IP address, so we have to convert our network address. So we need our network address or the IP address. So this one is 205.36.72.56. Okay. So we're given. So is the network address. This is all we need. Now we're going to convert this one into a binary form since this is a decimal form. Okay. So first we're going to convert network address to binary form. So let's do this one by one. So again, by using our table here, we put down the 205 on our first octet here. So again, 36 on the second octet here. Then we have 72 here. And the last octet is 56. So we have 56 here. So again, we are going to convert this one into binary using our values here. So we already know this one. So again, I'm going to ask again 128, and is this one can be used in order to get 205? Yes, so that's why we have one here. So a 64 can still be added to 128 in order to get 205. Yes. So what about 32? No, we cannot use 32. So what about 16? No, we cannot use 16. What about 8? So Yes, we can use 8. And what about 4? Yes, we can use 4. What about 2? No, we cannot use 2. And what about 1? Yes, we can use 1. That's why we have E1 here. So to confirm this, so 1 here, so meaning yes, so let's add 128. So 128, so meaning plus 64 plus 0 plus 0 plus 8 plus 4 plus 0 plus 1 is 205. So we all know how to get this one, right? So again, to confirm, just to confirm this one, we are going to add using our calculator. Okay, so 128 plus 64, we don't need a 0 anymore, so plus 8 plus 4 plus 1 is equals to 205. So we get the first binary form. So we get the first binary form of the first octet. So let's move on to 36. So again, we cannot use 128 to get 36. So this is 0 here. We cannot use 64. So we put 0 here again. And can we use 32 in order to get 36? Yes, 32. So we only have 2 left. So 32 plus 2 is equals, 4. We still need 4. Okay, so 0. We cannot use 16. And we cannot use 8. So all we need is 4. So that's why we have 1 here. And the rest is zeros. See? So to confirm this, 0, 0, 1, 0, 1. So meaning we add up 128 plus 64. No. We're in 36, right? So 32 plus 4. So only 32 plus 4 is 1. So we have 32 plus 4 is 36. So let's move on to our next octet. So we have a 72. So 72, we cannot use 128. So 0 here. We can use 64. So we have to put 1 here. So 64 again. We cannot use 32. But we can use 16. So meaning, again, let me check. 64 plus 64 plus 8. So 64 plus 8 is 72. So all the rest will be zeros. Okay. So again, this is this one here. 64, 0 plus 64 plus 0 plus 0 plus 8 plus 0 plus 0 plus 0 is equals to 72. Okay. So what about 56? So again, 128, we cannot use 128, so this is 0. So again, 64, still we cannot use this one, so 0. So we can use 32, so that's why 1 here. We can also use 16, so and we can also use 8, and the rest we cannot use this one. So it's all zeros. So to confirm this one, we have here 32. To confirm this one, 32 plus 16 plus 8 is equals to 56. So that's why we have 56. So we get the binary form again of 56. So this is its binary form. So 0, 0, 1, 1, 1, 0, 0, 0. Okay? So we're going to get the binary. So 205. So this is its binary form, this one. And the 36 is 001 001 00. Yeah, this one. And the 72 is 010010000. So the 72 is here. So it's 56 is 0011100. So this is the binary form of 56. So 0011100. Okay. So therefore, our IP address is 11001101 that 001001000 that 010010000 that 001110000. So this is our binary of the of our IP address. So this is our final answer. Okay, so the last number but not the least. So we're going to find what is asked. So number 10. So we're going to find again or get the broadcast address. So again, in order to get the broadcast address, we need to know the network address and the subnet mask. So we have 205.36.72.56, and our subnet mask is 255.255.255.248. So we are going to use these two in order to get our broadcast address. Okay, so this is our given. We have the network address and the subnet mask is here. Okay, again, we did this I think many times now. So we just need the network address and the subnet address to get the broadcast address. So again, looking for our rule. What's the rule? So if it is, I forget. If it is 255, so we're just going to write the network, the octet of the network address. So in this case, we have our first octet is 255, so we're going to write down again 205. So that's why we have a 205 here. So next is again we have again a 255. So let's just write down 36. So that's why we have 36 here. Again we have 255 here on our subnet mask, and so we are going to write down 72 on our third octet here. And on the last octet, so we need to solve this one because the octet is not 255 and also not a 0. So this is a funny octet. So we need to solve this one using our formula, which is 256 minus 248. So this one here, 248. So we need to subtract this one from 256. So 256 minus 248 is 8. So let me check again. 256 minus 248 is equals to 8. So 8. So we have now a multiplier of 8. So again, we're going to find a number which is greater than 56 and nearest to 56 by using our multiplier. So since we have a multiplier, we will use this 8. So we need to find a number which is a multiple of 8 that is greater than 56. Okay, so if we're going to add 8 plus 8, we can get 16. So is 16 greater than 56? No, it's not enough. Okay, so let's add again. So 16 plus 8 is equals to 24. Again, is 24 greater than 56? Not yet. So again, 24 plus 8. 32. Still 32 is not greater than 56. So again, we're going to add 32 plus 8 again. So we have 40. So 40 is still not greater than 56. So we need to get going. So 40 plus 8 is equals to 48. Still 48 is not greater than 56. So 48 again plus 8 is equals to 56. So 56 is still not greater than 56. It's equal to 56. So let's add again 8. So 56 plus 8 is 64. Now 64 is greater than 8, and 64 is also the nearest to 56 based on our multiplier here 8. Okay, so next is we're going to subtract 1. So meaning we have 64 minus 1 is equals to 63. So our missing octet here is 63. So therefore, our final broadcast address is 205.36.72.63. So this is our broadcast address, and this is our final answer. Okay, so I think that's all. So we solved and explained all our problems. So to sum up, let me check our objectives for this activity. So I think we already did convert the network address to binary. So we already converted some network address to binary, and we also have converted the a prefix length into subnet mask, and subnet mask to prefix length, right? So again, and this one identify the 3 types of addresses. So we already identified the 3 types of addresses, which is network address, the broadcast address, and the gateway address. So we already did our part, and I explained already my part on how I get the answers. So that's, I think that's all. And once again, my name is Mari John Igot, and have a good day. Thank you, everyone.